Hello, everyone, and welcome to the broadcast. I'm Sam Charrington, an industry analyst focused on machine learning and AI in the enterprise, and host of the popular TWIML AI podcast, a show I launched as This Week in Machine Learning and AI, some 4 years, 400 episodes, and 8 million downloads ago, to chronicle the many examples of innovation happening in the field of artificial intelligence. I'm super excited to be here with you today at VB Transform, along with Cloudera's Adam Warrington, to explore one such story focused on conversational AI. Before we dive in, Adam, please introduce yourself, Cloudera, and your role at the company.
Great. Thanks for having me, Sam. Hey, everybody. My name is Adam Warrington. I am a Senior Director of Engineering here at Cloudera, and I primarily focus on internal systems using data to make our company more efficient. Cloudera is a company that sells data software and a data platform that focuses on the modern data lake architecture.
Awesome. So you're not here representing Cloudera as a vendor, but rather as a leader who successfully deployed an enterprise conversational AI system. Let's dig into your use case a bit. Let's start with what drove you to explore conversational AI at Cloudera?
Yeah, great question. So like many other companies in the industry, we're looking at ways constantly on how we can improve our customer experience. Chatbots and conversational AI technologies are a really interesting way for us to provide more efficient responses tailored to our customers and the questions that they might have. In this particular case, we were focused on the support experience for our customers. And so we were exploring ways that we can more efficiently answer our customers' support questions. When they run into issues with the software that they're using, are there ways that we can provide relevant answers to their questions more efficiently? And chatbot software was something that really kind of stood out to us as a channel that would be useful to explore. Here's what we found. We were primarily looking at off-the-shelf chatbot software, right? We're not a company that sells chatbot software, as you said, Sam, right? So we were looking at off-the-shelf chatbot software, and what we found was that most companies that start using chatbot software, they tend to dip their toes into the water at first. They don't go full steam ahead and deploy out of the gate some kind of conversational AI type system, right? The way that these things usually work is you'll deploy a simple use case initially, and the chatbot software, especially the stuff off the shelf in the market today, it will learn over time based on how the customers and the users of that chatbot are utilizing it, and the signals that you can take out of the chatbot software itself. So we were kind of interested in how we could possibly use our own data sets and technologies that we had internally to do something a little bit more than just dipping our toes into the water. We were more interested in getting off-the-shelf chatbot software that was extensible through APIs, and using this wealth of data that we have here at Cloudera, about interactions that we've had with customers, support cases, community posts, all this type of data that we store internally. How can we leverage that to provide real answers to our customers out of the gate without some third-party chatbot software having to learn our domain and our space? And so that's exactly what we did. We were able to integrate those systems, a piece of off-the-shelf chatbot software, as well as our modern data lake architecture that we run internally. And we were able to bring to our website a piece of chatbot that could, based on descriptions of issues that our customers input into the chatbot, could then return relevant answers that, with a high degree of probability, we think will address the customer's needs.
Awesome. What a great story. You mentioned some of the signals that we typically get from these off-the-shelf conversational AI software, and we often hear about features of dialogue systems like entities and intents, but much less about how we can make these systems intelligent and ensure that they're delivering relevant information to their users, which is what your effort focused on. Can you take us a little bit deeper into how you went about tackling this challenge for your project?
Yeah, I can. So here's essentially what we did. We took data sets of customer issues as well as solutions to those customer issues. And our goal was to extract out the semantic context of those issues. So if you, for example, think about a support case, right? In a support case, you're going to have a lot of back and forth dialogue with the customer. Part of that back and forth is going to include, the description of the issue. Part of it's going to include things that are more have more to do with sort of the management of the case itself, like, hey, when can I get an update on this case, or can we raise or lower the priority of this case? And so what we were able to do was we were able to build models that could understand what parts of the support case were actually technically relevant to that support case. And so that was our goal, was to build these models, whether it's support case or community posts, that could look at that, understand which words, which sentences are relevant to the support case, as well as then extracting out the solution to that support case. Whether that solution is a knowledge base article or product documentation or another community post or something along those lines, right? And when you're able to actually do that, what you have is this library of descriptions of known issues, right? That you've extracted out of this content that when you plug a piece of chatbot software into it, where somebody is giving as input a description, you can do similarity between those things and return similar relevant results as we have done in the past through this historical data set.
Now, when I hear machine learning models, I think of fancy technologies like deep learning, or for folks that are really familiar with the cutting edge, transformers. Was this a research effort, or was this a straight engineering effort?
This was a straight engineering effort. There was some amount of research, as is the case in many engineering efforts, but the vast majority of this project really was about engineering. Our goal wasn't to deploy the latest cutting edge, machine learning models, deep learning, et cetera. What we actually found, we experimented with a few different models in our ability to extract out, this technical semantic context from these data sources. And we found that simple models like naive Bayes, for example, work really, really well on this kind of problem space. And as we grow and mature this particular approach and this particular implementation, we very well could go and explore more advanced techniques, more advanced models as we add more types of signals into the system. But out of the gate, to hit the ground running, using something simple, we found that you can actually provide very useful results to the customers very quickly using these kind of approaches.
When you talk about the utility of the results, often we think about relevancy as a subjective type of metric. How did you measure the results of your efforts in terms of that relevancy? And did you have some kind of target or baseline that you were evaluating your results against?
Yeah. So, with a machine learning problem like this, you're breaking the problem down into subproblems, right? And so one of the subproblems is, how do we understand what's technically relevant to our data sets? And in this case, we use our subject matter experts, right, to label and train a data set, this data set that we have internally. And so we process the data into normalized form, and then hand this off to those subject matter experts and ask them to manually label and classify some of these data sets. The work can be a little bit tedious, as is the case with many machine learning projects, but you don't need, in this particular case, millions and millions of things categorized and labeled. After about a week of some effort, we were able to have a great data set that was labeled that we could use then for training and testing. And our goal was to hit right around 90% accuracy for this, and we were able to do that. We got 90% accuracy for that. Now, there's the derivative problem downstream, which is, what we actually want to do is we want to provide answers to the customers that are relevant to their problem. It's not just about understanding what's technically relevant and what's not. And there again, we're using our subject matter experts to measure those results initially. Since we're hitting the ground running and not basically using a large historical signal from our customer base, what we used instead were our support engineers, our experts, to ask them to really kind of measure, okay, if a customer describes something in this way, are we returning relevant results? What is the expected solution? Using ways that our customers have described them in the past from that library of data sets of community posts, as well as support cases. So all that to say, we used our subject matter experts internally. And as this project continues to go on in the public space, we expect to get more signals from our customers that are actually using the chatbot now, right? And so we'll start to use those inputs, those signals from our customers to really expand on our test sets and our training sets to improve the quality from where it's at today.
So you're able to achieve your technical goals, but it sounds like one of the key achievements of this project was the overall time to market. How long did this effort take actually? And assuming you were able to move quickly, what were the prerequisites to moving this fast?
Yeah. So from inception of the problem statement of trying to use our own data sets and our own technology to augment chatbot software to return relevant results based on customer problem descriptions, this took under a month. This took a matter of 3 to 4 weeks for us to actually roll this out. That might seem unbelievable, but there's a couple of reasons that we were able to iterate so quickly here. Number one, we run a modern data lake architecture on top of Cloudera's own technology that we sell to the market. What this means is all of our data sets are already in this data lake. All of our processing capabilities already exist on top of this. So everything from analytics to operational databases to our machine learning systems and things like Spark. We're able to access these data sets through these different technologies. And what this means is we were not only able to do the AI and ML portion of this, but also the operational portion of plugging those same models and data sets into the chatbot through its APIs. We were able to accomplish this very, very quickly. And so, on top of that, we were able to leverage pre-existing machine learning work. Right. And so that's sometimes a long pull, like categorizing data, testing different models. It turns out when you're running all of these machine learning projects on an architecture like this, you can share work that has been done in the past that you didn't necessarily expect to use in this way. And so some of these models were already built. We were working on these types of approaches for making our own internal engineers more efficient in finding solutions across our product stacks when our customers run into issues. And so when we were looking at chatbot software, we said, oh, wow, we already have these models. We already have all this processing. It's all on this same data lake where all the data is. Let's experiment, see if we can actually make this return relevant results the way that our customers describe issues through a chatbot. And it turned out very, very well. So, the prerequisite for being able to move this quickly is making sure that you're not building, data silos, right? That you're not doing work in siloed areas. When you kind of put some thought into it, you're running a modern data architecture, you're able to actually leverage that work in the future, possibly for use cases you never expected. And in this case, it led us from, within a matter of weeks, going from the inception of a problem to actually rolling out on our website.
Fantastic. You mentioned at the start that one of the desirable properties of the approach that you ultimately took was that you could get your chatbot to achieve some degree of intelligence more quickly than what you saw with off-the-shelf solutions where the system evolved over time. But I imagine that you still want your system to evolve over time. Can you have your cake and eat it too?
Yeah, we absolutely will evolve our system over time. when we set this up, we're taking in all the signals, how our customers are using the chatbot, how they're interfacing then with the results. Are the results relevant? Are they still going and opening a support case after they get those results? Do they reference what they did in the chatbot when they open up those support cases? We're planning to use that all as signal to continuously iterate on this model. So, possibly once a month, maybe even at a higher cadence, depending on the types of iterations we're looking at doing, we're going to be rebuilding our models, rebuilding our indexes to, take into account those different signals and provide higher quality results to our customers. And so, it's an ongoing effort, Sam. These types of projects are ongoing, especially once you prove that the business is going to get value, the customers are going to get value out of this sort of approach. You want to continue to double down on those investments and get more value, provide better experiences to the customers.
And so does this project and what you've achieved with it, does it give you a leg up in tackling future conversational AI projects?
Yeah, that's what we're planning. We're looking at basically these metrics of how customers are using the chatbot, other areas of where customers are kind of exiting the chatbot, possibly opening up support cases, possibly reaching out to marketing, or whatever channels that they're actually trying to accomplish or reach through the chatbot. We're looking at that as part of those signals. And so, we're going to grow our use cases beyond just describing issues, right? We would like to be able to help our customers through a variety of different ways. This is just kind of where we started, Sam. And we started with, an area where our customers, we think our customers are going to get the most value and continue to be impressed with our company and the service that we provide to them, and also allow us to run more efficiently and invest, more resources in the areas where it's needed.
So Adam, end of the day, what advice would you give to a technical or business executive that's looking to get started in this area at their company?
Yeah. So, first and foremost, don't reinvent the wheel is advice number one. Look at off-the-shelf chatbot software. But my recommendation is if you're not just going to use something as is off the shelf, if you want the ability to expand and extend and to use your own subject matter expertise that you have internally, look for chatbot software that is extensible, that has good APIs and is easy to expand upon. Then you have to look at the problem you're trying to solve, right? And work with your subject matter experts internally at your company to understand, do we actually have data sets? Do we have ways that we can, approach this problem where, we can utilize our own data sets, our own knowledge to expand and build some facet of a conversational AI type of system on top of off-the-shelf chatbot software. And then third, I would just recommend looking at data architecture. If what you're finding is you go down these roads and you're hitting blockers, oh, we have to get this data over here. Oh, it's going to take us months to, experiment with this thing over here and then move it. That kind of thing is indicative of the fact that there might be a data architecture problem. And you want to be able to move fast and very agile. And so, in parallel to this, I wouldn't recommend holding off on all chatbot stuff, and all possible chatbot type work, until you have a proper data architecture. But it would be, I would advise that taking a look at that data architecture, making sure that you do have a modern data architecture that allows you to operate in an agile way will make building these kinds of systems much, much easier down the road.
So understand your problem, understand the data that you need to solve it, and use it as an opportunity to advance your data architecture if you don't already have a modern one in place. Adam, thanks so much for this conversation.
Thank you, Sam.